Vectors are something that you're going to come across an awful lot in physics. So a vector is something which has both a magnitude and a direction. A scalar, on the other hand, is something which only has a magnitude. So some things that we measure are scalars. So for example, time is a scalar. It doesn't make sense to give a direction for time. We can't go 9 minutes north, for example. Volume is another quantity which is a scalar. It does not have a direction. But for many things we want to describe, it's more useful to describe them with a vector, so with something that has both a magnitude and a direction. So for example, if I wanted to know how to get to the nearest bus stop, it wouldn't be very useful for you to tell me that it is 1 kilometre away. That's a distance, which is a scalar. This would give me the location as a circle around my position. I wouldn't know in which direction to head to get to the bus stop. So it would be much more useful if you gave me the directions to the bus stop as a vector. So if you said, for example, the bus stop is 1 kilometre north, then you've given me both the magnitude, the 1 kilometre, and the direction north. So now I know exactly which way to walk. When we're representing vectors, we often represent them as arrows. So when we do this, the length of the arrow is proportional to the magnitude of the vector, and the direction the arrow is pointing indicates the direction of the vector. When we're writing down vectors in equations, there's several ways that we can show that the quantity that we're talking about is a vector and not a scalar. So some of these common ways are to write it in bold typeface. If we're writing it by hand, we often draw a little squiggly line underneath. And often they're also written with an arrow over the top. So all these notations indicate that the quantity in the equation is a vector. If we just want to consider the magnitude of the vector, so the size of the vector, then in an equation we'd draw the absolute value signs, straight lines, around our vector. This indicates that we're ignoring the direction and just considering the magnitude.